Hello everyone, and welcome to our final presentation for 414 from the B team. Just as a quick refresher, we are myself, Ben Gillette, and I'm a senior in computer science, Ben Rayford, who's also a senior in computer science, Matt Messina, who's a senior in ACT, and Eric Leip, who's a master's in computer science here at CSU. We're super excited to show you what we have, so I'll go ahead and dive right in. I'll begin with a brief explanation of the variant of chess which we implemented, known as Ligand chess. Maybe you've seen this before, but just in case you haven't, Ligand chess is pretty much like regular chess except for a few differences. The pieces start in the corners instead of along the two base rows of the board. Pawns don't move forward, instead they move diagonally, and to capture, they can move up or sideways, as shown in these diagrams we've got here. The pawns are not promoted on the home row, like in regular chess. Instead, they're promoted when they move to the opponent's far corner. So those four squares along either side that have the dots on them, those are the valid promotion areas. Like in regular chess, you can promote a pawn to any of the four standard choices from regular chess, those being bishop, knight, rook, and queen. There is no castling, which is a little bit simpler, and there's no en passant as well. So that's the game we implemented, and here in a minute you'll get to see us actually play it on our website. Let me talk about our process a little bit as well. We used IntelliJ, ZenHub for our Kanban board, Discord for communication. As far as deployment goes, we put our website up on Amazon EC2 and used an RDS instance, also part of AWS, to host our database. We use Google OAuth to log in and out of our application, which is kind of cool. You'll see that here in our demo in a minute. We signed our website in HTTPS with Let's Encrypt, so it's actually secure as well. We wrote the backend in Java, obviously, using Spark. And our database was Postgres, and we used JDBC to communicate with it. As far as the front end goes, we used React.js and pure functional components, so no class-based components, similar to what you might have seen in CS414 if you've seen that class, but of course, like I said, not class components, but functional components. I'll talk a little bit more about our pipeline later in this presentation, but now I'm going to move on to the process. Of course, we were doing Agile with Scrum and had sprint planning meetings pretty frequently, and had retrospectives and reviews as well to reflect on our process. Moving then to the design aspect of this project, I want to talk a little bit about some of the motivating factors that went into our decisions for how we would lay this out. So I'll go over the back end first. Of course, we're in Java, so it's fully object-oriented, and we needed to figure out how we're going to represent the state of the board and the state of all the connections going in and out, how we're going to manage the database, and talk to our front end. So there was a lot going on there. As far as the actual chess game goes, we wanted to separate it into logical components. So we have a chess piece class, a board class, which contains all the pieces, and then the match, which characterizes each game individually. Because the match is more than just the game, we also need to keep track of information like when it started and who's playing, whose turn it is, etc. We used an abstract piece class because we recognized that all the chess pieces, though there are quite a few different types of them, are pretty similar as far as the way you would want to interact with them. So we decided to put all those traits in the abstract class and allow each specific piece to inherit from them. The board's responsibilities were primarily aggregating the pieces, keeping track of where they actually were on the board, and validating the moves. Our client would request, we want to move this pawn from here to here, and the board's job was to determine whether or not that was a legal move. And of course, there's a lot of factors going into that, like whose turn it is, what color the piece is, whether or not that piece is able to move there, and whether or not, you're doing a capture or a promotion or other things like that. So those were the responsibilities of the board. And then the match keeps track of, like I said, sort of the metadata for the actual game. So the IDs of the players in the game and time and other things like that. Some of the design patterns we used were wrapper classes and adapters to allow us to interact with our database and save information in persistent storage. Of course, we could have saved it all in memory, but we were really excited about the possibility of being able to restart the server push a change or something, and have all the match data, all our profiles, the games, everything like that, still be there, and not get thrown away from being in memory. So we used a database to permanently store this data, but we also needed a wrapper class around it to allow for sort of cached access to the database. Because, of course, you don't want to be rapidly saving and loading data from the database. So we sort of used both in-memory optimizations and database for permanent storage. This also made it a lot easier to do asynchronous gameplay since we didn't ever need to depend on something being in memory, and we could focus on the players who were just connected at this point in time. Here's our class diagram. As you can see, it's pretty complicated at this point in time, but this does characterize all the different classes we used. We tended to write smaller classes with fewer responsibilities and have more of them, as opposed to having a bunch of massive classes. You can see it's not too much to follow. We also did a traceability link matrix, and you probably can't even see this very well, but this describes what the relationship between all of our different classes and the user stories we were tackling is. This sort of helps us keep ourselves honest when we're doing a feature, saying, what does this class actually do with respect to what we're trying to get done in the user story. So I'm going to go ahead and jump into a demo, and I've actually got my team here with me, and we'll show off a few of the cool things we can do with our application. So I'll go ahead and show some of the process to play a game, and we're starting with logging in. So I pointed my web browser to bteamchess.com. We did actually go ahead and deploy this live, which is pretty cool. We're hosting it on AWS EC2. Our login process, as we've talked about a little bit before, is based on Google OAuth. So we don't need to store user credentials in our database, and that means we're protecting our users more, and it's just safer and more secure all around. Instead, the user signs in with Google through our web page, and then we get a token back that we can use to verify it was actually that user who logged in using cryptographic signing. So we'll go ahead and click on the Sign In with Google button. It brings up this standard little Google login window. I've already logged in with a few accounts on this computer, so I'm just selecting the one I want, my personal email. Spins for a sec, and then it brings me to the main page of our web application. And since it's a new account, it's asking me to set my nickname. So I'm going to go ahead and do that. This is the name I usually play games under, and I set that, and you can see it is now recognized that that's my nickname. Over here, we've got a little profile info window, so I could change my nickname if I want to. You can completely delete your account and remove it from our system, and that takes all the games you've played with it too. Or you can just log out and go back to the main page. It also supports staying signed in, so if I reload this web page, we come back, and it automatically remembers who I am and signs in. Pretty slick. So my teammate Ben has also logged in our web application, and we're going to play a match together. So we can click New Match, and only one of us has to do this, and it brings up the Invite Another Player prompt. You have to know their email address, so I'm going to put in his. gmail.com, invite, and then you can see it's got his profile picture, and we've got Metaname versus Big Ben. So that's my nickname, that's his. I have a cancel invite button that I could click. I'm going to try that out right now. And that deletes the match. And it will have disappeared on his side too. Let me send the invite again. Our invite is back, and on Ben's side, he has the option to accept or decline this.
So I'm going to hit accept on Ben's invite, and we'll now be put into a new League and Chess match together.
And notice that the match immediately updated on my screen. I never had to click refresh or anything. As soon as he clicked accept, the state of the match was updated in the server, and both of our clients were notified. This is the list of matches that you're currently in, and it scrolls, so you can fit a lot of history in here. You can see we've got the name of the match, whose turn it is, the color, and the start time. And it's all live updating. So as soon as any of your matches update, someone else makes a move, it'll show up here as well as in-game if you've clicked on it. So we'll go ahead and go see what's going on in this match. When you click this, it takes you to our chessboard, so you can see we've got the standard League in Chess starting position. We've got the title of the match, our profile pictures that came from Google, as well as the name of the player whose turn it is, as well as their color. So I'll go ahead and make the first move. In League in Chess, pawns move diagonally, so that is a legal move. And I just made the move. Notice that the turn updated, so it's now Black's turn. And on Ben's screen, he sees that it is now his turn, and if he was in the match page, the chess piece would have actually moved without him needing to reload.
So here we're going to demonstrate that we can have multiple matches at the same time. So while I'm while I'm participating in a match with Ben, I can also create a new match with Matt and we can play each other and make moves in that game as well. So here's an example of how I'd start a new match. Click the new match button, enter the opponent's email just like we did before. Matt should then receive an invite to the game.
I'll click accept.
And great. And then as soon as Matt clicked accept, it updated on my end here. And then since I invited him, I'm the white player and we'll have to start. All right, so I just made the first move.
So here you can see the client from Matt's perspective, where he's logged in on his machine. And you can see that he just saw Ben's move and is able to try to make a move himself. And this is how our client deals with illegal moves as well. It just snaps the piece back. So one of the interesting features of League in Chess is that it actually does have pawn promotion in the rules. In normal chess, as you're all probably familiar, if you get a pawn all the way to the back of your opponent's board, you can choose to promote it into a variety of different pieces: bishops, knights, rooks, or queens. In League in Chess, you have to get it onto one of the four primary piece starting squares in your opponent's corner. So you can see the pawn here on b5, and it's my turn, is about to be able to move onto a6 and get promoted. So we just wanted to show you what happens then. I'm going to move this onto here, and before sending the move, my client will ask, select a piece to promote your pawn to. I'm going to go ahead and take a queen because, best piece. And you can see I was just given a queen here on the board. One other thing I wanted to talk about in this presentation was our CI/CD pipeline. It belongs a little bit more with the process and tools, but I figured I would break it up because the demo is a little bit more interesting than this. But what's going on is we've actually set up, using GitHub Actions, you're looking at our repository right now, some continuous integration, continuous deployment pipelines that automatically build our code, run tests, and deploy to our production instance every time we do a pull request. So we're looking at all the different times we've done a pull request recently. And if I want to specifically look at this one, I can see it built our Electron app, that's the standalone desktop for Ubuntu and Mac, and also deployed to our production instance. And that's the continuous deployment. So I didn't actually have to do any SSHing or deploying or reinstalling or anything. All that it needs is for our EC2 instance to be live and running, which it is. And we just merge the pull request and it automatically deploys and goes live at our website. This is pretty neat. And while it wasn't strictly required, I wanted to show it off because it was really fun and we all learned a lot doing it. Finally, I'd like to reflect on some of the takeaways we have from this semester project. First, it was more difficult for us having only 4 instead of 5 or 6 teammates, especially since we lost them in the middle of the sprint and had a hard time sort of recouping the work they had. But, that's to be expected and we did our best to bounce back. Planning for future improvements is actually pretty important. So in Agile, of course, we're trying to strike a balance between planning the entire project before coding at all, and then the other extreme being, doing no planning and just going straight into the code. But we definitely had a little bit of difficulty coming across unexpected difficulties after having set out on a certain path and needing to change our plans. That being said, flexibility was key in being able to get things done. And the more we communicated and explained what things were supposed to do, even if we weren't the one writing it, making sure we were all on the same page and delegating tasks to each other, those were some of the keys that helped us actually get things done. Thanks everyone for watching, and cheers to the end of the semester.